Hello, this is the genuinely approachable Sudoku for the 6th of January 2024. It is Region Sumlines by Clover. So what are the rules of the puzzle? Normal Sudoku rules apply, so 1 to 9 in every row, every column, and every 3x3 box. Each blue line passes through multiple regions in the grid. So this circle passes through this, and this. Along each line, the digits within each region have the same sum. So these two digits must have the same sum as these two digits, which must have the same sum as these four digits. Yeah, different lines may or may not have different sums. So that is just like a no negative constraint kind of extra rule. But those are the rules. With that, let us begin. So, what do we start with? We can do normal Sudoku first. These two 5s see these cells, so 5 in this box can only go here. Okay. Well, by region sum lines, these two cells have to sum to the same as this cell, so these two just sum to 5. The only way to do that is either with a 2-3 or a 1-4, and you can't have a 1-4, so these are a 2-3 pair. We can do the same up here with this 5. These must sum to 5 but can't be a 2-3, so it's a 1-4 pair. I think next we look at the big circles. Or do we look at these? Yes, we do, because this 9 has sees these cells. These cells must contain a 1, because if it contained no 1s, then the minimum you can make this is, without the 4, a 2, 3, 5, which adds to 10. So this would be at least a 10 without the 1 in there. So there must be a 1. The remaining cells add to 8. And could be a 2, 6 or a 3, 5. We don't know. Okay, what about this? This 8 must have a 1. Because without the 1, you'd have a minimum of 3, 4, 5, which adds to 12. So this must have a 1 somewhere. There can't be a 1 there. These ones, look at that, removing a 1 from there, so that's a 4 and that's a 1. More importantly though, the remaining cells forming the 8 must add up to 7, and can't be a 1, 6 because there already exists a 1. It can't be a 2, 6, it can't be a 1, 7 because there exists a 1. Wait, what? No, sorry, it can't be 1, 6 because there's already a 1. It can't be 2, 5 because it already has a 2. The remaining must add to 7, and therefore has to have a 3 and a 4. So these are 1, 3, and 4. This 4 sees both of these cells, so that has to be where the 4 goes. This is a 1 and a 3. In this box, 3 sees these cells, this 3 sees these cells, these 3 sees that. So that's a 3. And I think we have to look at the huge circle now, because this cell, or these two cells, sum to these cells, and that actually is very interesting. How small can you make this? Well, with 1, 2, 3, and 4, you can make this a 10, right? At least a 10. But then how big can you make this? Well, with the 1 here, the only other digit you can put here is a 9, making this at most a 10. So this has to be the maximum, while this has to be the minimum. Meaning that this is in fact a 1, 9. And the reason why is if this was any smaller, you couldn't fit that amount into 4 cells. So if this was any bigger, you couldn't fit a bigger number into these 2 cells. So it is bounded above and below at the value 10, which means that you can't go above 10 or below 10, which means it just has to be 10. So that's a 9 to form 10. And by similar logic here, these cells, not that one, these cells sum to these 4 cells, which means that because we already have proven that this is bounded by 10, this has to be the 9. The same does not apply in these cells, although I do see what's going to go on here, because this is once again a 10 at minimum. This does not seem like a 10 at minimum at first, but we already used a 9 in the box, so this actually cannot have a 9, meaning that at maximum you could have a 2, 8 forming a 10. So this is in fact still bounded at 10, which means that this has to be an 8. By similar logic, this has a maximum of 10 as well, because this can't be a 9 or an 8, so that's a 7, and then that's a 6. And then all of these, if I can uncolor these cells. All of these sets have to in fact sum to 10. Now this one sees both of those cells, so that's a 1. These two ones see those cells, so that's where 1 goes. This is no longer a 1. This one sees those two cells, so 1 goes in one of these. These ones see that cell, this one sees that, this one sees that, so 1 goes there. Oh, wow, interesting, we can't actually get a 1 here at all. But okay. This one sees that, so that's a 3, that's a 1. This 3 sees that, so that's a 2 and that's a 3. Okay. 3, oh right, I forgot to say, because these sum to 10 and all must be the same digit, they must be just 1, 2, 3, and 4, which is something that I should have pointed out. This 3 can't go in those cells, so that's where 3 goes. 2 can't go in there, so that's 4, and that's 2. 4 can't go in that cell, or this cell, so that's where 4 goes. 3 and 1 can't go in here, 4 can't go in there, so that's 2. This is a 1-3 pair, which is resolved by that, so that's a 3. Sorry, that's 1, that's a 3. These sum to 10, which I didn't say, so that's a 6. These sum to 10, so that's a 7, and these sum to 10, so that is an 8. This one, by the row, has to be a 7. These two cells are 3 and 9, which is resolved by that, so that's a 9, that's a 3. Wait, 3 and 9? No. 8 and 9. What am I saying? That is resolved by that, so that's a 9, that's an 8. These two cells are 6 and 7, which is resolved by that. This cell is a 9. 3 can't go in any of these cells, so 3's there. This is 2 and 4, which is resolved by that. 2 here, 4 there. This is 2 and 4, which is resolved by that. And we have all those complete. What else do we have? In here we have 5 and 6, which we haven't resolved yet. These are therefore 7 and 9. This 7 disambiguates that. These are 5, 7. Also haven't fixed that yet. And these are therefore 6, 8, which is resolved by that. Okay. Next. Oh, I guess in this column, what are those cells? 4, no, not 4, 5 and 6. That forms a 5-6 pair here, meaning that in this row, this is an 8. We can do something similar, I believe, in these, maybe? No, this 9 is not resolved yet. Yes, the 9 must have a 1 in it, so the remaining cells have to add up to 8. 1, 7 is not available because 1 already exists in here. 2, 6 is not available, so it has to be 1, 3, 5. This can't be 1 or 3 by those cells, so that is a 5. This 1 means that's not a 1, so that's a 1, that is a 3. This 5 fixes that, it's a 6, that's a 5, that fixes this. Here in this row we have 9 and 6, 6 and 9. 6 resolves that, 9 here, 6 here. These cells are 7 and 9, this 9 resolves that, 7 here, 9 there. 2, 5, 2, 5, 6. These are 2, 5, 6. 2 and 5 see that, so that's a 6. 5 sees that, so that's a 2. That's a 5. These cells are 7, 9, resolved by that. That is a 2. This is therefore an 8. This is a 5 or 7 in the row, which is resolved by this 7. So that's a 5, that's a 7, that's a 5. Here in this row, this must be a 7. The remaining cells are 4 and 8. So 4 here, 8 there. Solved. Okay, well this was a fun puzzle. I hope you enjoyed this region sumlines puzzle. Thank you for watching. Bye bye.